Okay, we're going to jump in here on our third lesson on proportion. And really, this is just sort of putting together the basic ideas of ratios that we introduced in the first one and the quick method of solving the special type of equation that comes up from these scenarios that we looked at in the second lesson. So again, I'm not going to read it all out there, but you can see where this specifically is taught in Math 026, 038, and 052. And for Math 053, certainly ratios and equations that you can solve with the cross product do continue to come up, and definitely word problems, as you already know, in, for example, your equation solving unit and your linear graphs unit as well. Word problems basically make their way in everywhere you go in pretty well all these courses, actually. So let's just start with a quick reminder of how we solve this special equation. And I'm going to say once again, remind you what this special equation is. We see there's an equal sign. If there's not an equal sign, do not use cross products. Do not cross multiply. So we have an equal sign. And on either side of the equal sign, we have a single fraction and nothing else, right? That is the one type of equation that this special little shortcut we looked at works on. So I'm going to give you 2 minutes to try those, and then we'll go through them together. Then we'll pick up on where we're taking this next. Okay, so as a reminder, our fast way of doing this is to recognize that this is the special pattern that our shortcut works on and identify the cross product that doesn't have a variable in it. So in this case, that is the 5.7 and the 80. And the variable h will be equal to those two multiplied together, divided by the other one, which I've circled in blue there, like so. And that is the quick way to do this. And if you punch that into your calculator, you get 7.238095. Does it give us? Yes, it tells us to 2 decimal places you see up here. So I'm going to round this. Look at that 3. The next digit is an 8, so it rounds up to a 4, like so. Now, if you do like the cross multiplying, that's fine. And in some ways, it might be better. Because shortcuts are great as long as you understand when to use them. Although even cross multiplying technically is a shortcut, as we saw last time. This is really just clearing fractions like we've learned to do in Math 053, Chapter 3. So the cross multiplying method, I take the two cross products and I set them equal to each other. So color coding didn't happen there. 5.7 times 80 in blue, 63 times h in red. And then I divide both sides by 63 because that will make the h become by itself. And I'm not going to carry on going down there because you can see we end up on the left with exactly the same thing. 5.7 times 80 divided by 63. Look over here. 5.7 times 80 divided by 63, right? So cross multiplying just has that extra step along the way. But if you like that and if it makes sense to you, that's great. All right, let's look at this other one. I recognize that it fits this special pattern. I identify the cross product that doesn't have any variables in it, and I know that m will be equal to those two multiplied together divided by the other one, which is a 12. So that's 5,779 point a bunch of stuff. They want 2 decimal places, so I round to 2 decimal places like so. And that is our quick method for solving this special equation that is going to come up in all of our word problems today. So, and here is yet another reminder of that. We had this exact slide last time. So situations when you can use the cross product, a single fraction is equal to another single fraction, right? As we see on the left here in all those situations in which you should never, ever, 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 under any circumstances, take cross products when you have 2 fractions being added or subtracted, or multiplied or divided, anything other than set equal to each other, or when you have not just a single fraction equals a single fraction, but you have other stuff on either the right or left side being added or subtracted as well. Okay? So let's look at some word problems here. A doctor prescribes a certain medication based on the weight of the patient and using the ratio of 6 milligrams for every 20 pounds. How much should she prescribe to a patient who weighs 174 pounds? So what we're going to want to do is set up, first express the scenario that's been described in ratios, and including an unknown value, a variable for the thing you want to find. So we've been told that the doctor uses 6 milligrams of medication to every 20 pounds of weight. So that is one of our ratios, and that is going to be the same as how much should she prescribe to a patient who weighs 174. So I want you to notice a few things here. I put milligrams on the left, so milligrams has to be on the left again of the ratio over here that is equal to, and the pounds on the right, and the pounds. So it's milligrams to pounds on one side of the equal sign, and milligrams to pounds also on the other side of the equal sign. We know that 6 milligrams goes with 20 pounds, and we are asking what goes with 174 pounds. That what in math, of course, we don't write question marks. We use a variable, and I'm just going to use n for number, just kind of generically in all these questions, and that saves us the hassle of trying to think of what variable to use every time. So that's step one. Recognize the ratio that you know both numbers in, and the ratio with the thing you're trying to find. How many milligrams for 174 pounds? Step two, we're going to turn those into fractions, like so. So 6 to 20 becomes 6 over 20, and n to 174 becomes n over 174. And now we're just going to solve that by making use of our cross product shortcut. So this cross product here is a 20 and an n that has a variable in it. The other cross product, 6 and 174, is the one without a variable. So, yeah, and then the other number is a 20. So I multiply the cross product that doesn't have any variables, and then I divide by the other number. Work that out in your calculator. You get 52.2. And so, did I hopefully write a sentence answer? I did. Good. The doctor should prescribe 52.2 milligrams to this particular patient. So that's the basic idea. You're going to see they all fit very similar to that. Let's see, a crunchy, crispy treat chocolate bar. I asked my daughters to make up a name of a chocolate bar for this example. That's what they came up with. Has 285 calories and is broken into 12 squares. Johan likes to snack on crunchy, crispy treat bars, but doesn't want more than 150 calories in his snack. How many squares should he eat? All right, so step one, we're going to express this in ratios. So 285 calories in 12 squares. There's the ratio where we know both of the numbers. 150 calories, how many squares? So 285 to 12 is the same as 150 to what? And again, we replace those question marks. We use a variable to represent the thing we're trying to find. So n squares. Step two, turn them into fractions. 285 over 12 equals 150 over n, the variable we're trying to find. Step three, solve by making use of our cross product shortcut. So I see the 12 and the 150 is the cross product that doesn't have a variable. So I know that n will be equal to 12 times 150, then divided by the other number, which is 285. Turns out to be 6.3158, and let's see, well, it said how many squares should he eat. So I'm thinking Johan isn't planning to break off 0.3158, so let's assume he wants the whole number. Johan should eat 6 squares. Otherwise, he's going to go over his 150 calorie limit. Try another one. When returning from a trip to India, Juvie went to the bank and changed her remaining 2,000 rupees, that's the Indian currency in India, to Canadian dollars. The exchange rate on that day was $1 Canadian is equal to 62.44 rupees. So hopefully you're starting to recognize this pattern where we are always given a ratio, a complete ratio, right? So we know that 2,000 rupees is, well, I've actually turned it around here. Let's write the whole thing. We know that 62.44 rupees, I should have said, is the same as $1. So there's one of our ratios. And what we want to find is how many Canadian dollars go with 2,000 rupees, right? So you have a pair that gives you the relationship, and then you have a pair with the thing that you're trying to find, which in this case is how many Canadian dollars Juvie is going to get. So there's step one. Set up your two ratios that are equal to each other. Turn them both into fractions, which is the easiest part of the whole question. Just 2,000 over n equals 62.44 over 1. And now we're going to solve with our cross product shortcut. Find the cross product that has only numbers, no letters. So n is equal to those two multiplied together. There's the other number, 62.44, divided by that. And we get an answer of 32.03. And again, it didn't tell us how many decimal places, but we're talking about Canadian money here. So I think we can assume $32.03 or 32.03 Canadian dollars would be what Juvie would get from the bank when she goes to do that exchange. Cece is mixing 2-stroke oil with gasoline for her lawnmower. The label says to use 3 milliliters of oil for every 0.12 liters of gas. So you notice again, there's your complete pair. That is one of the ratios. Cece has a full jerry can that holds 4.25 liters. How much oil should she use? So set up your ratios, and why don't you give this one a try, and then we'll look at it together after you've done that. Okay, so let's take a look. We want to express the scenario in ratios. So we have our full pair that 3 milliliters of oil goes with 0.12 liters of gas, like so. And then that is equal to how much oil goes with 4.25 liters of gas, which is what we want to know. So again, you'll always have a complete pair of numbers that go together, and then the other pair with one number and the thing you're trying to find, which you want to use a variable for. Step 2, easy, turn it into fractions like so. And now we're going to solve using our cross product trick. The pair that does not have any variables is there in red this time. And so we know that, and there's the other number, 0.12. We know that n will be equal to the cross product multiplied and then divide by the other number, like so. And we get 106.25. Let's look back at the question. I don't think they gave us any specific rounding instructions, so we could do whatever we wanted here. I wouldn't round unnecessarily if they don't give you instructions, so I wouldn't take that to 106 unless they specifically told you to go to the nearest whole number. So Cece should use 106.25 milliliters of oil to mix up her gas for her lawnmower. And that is the last one. So there's the basic idea. Again, you see it always results in that one special formula, that one special type of equation that we can solve with our cross product trick. And you're always looking for the two ratios, the one with complete pair that tells you what number goes with what number, and then you're looking for the pair that has the thing that you are trying to find in it, how much oil with 4.25 liters of gas.